Hello, geometry. I hope you did well on your tests. I'm grading them now. So we're starting on chapter 8. The first section hopefully is a review a little bit for you. I know I taught it last year in algebra. It's the Pythagorean theorem and the converse of that. So hopefully you remember a little bit about that. The Pythagorean theorem itself says that if triangle ABC is a right triangle, okay, so we see our right angle down here. Then what I know is that c squared equals a squared plus b squared. And I know we don't always like to see it written this way. I know you prefer the other way around, but I really would like for our hypotenuse to be listed first. And our hypotenuse is always alone. That's the most important one to distinguish. So if we take a look at our right triangle and we draw this picture over here, triangle A, B, C. My hypotenuse is going to be C. I always label it like the letter across from the angle is how I call it. And since C is our hypotenuse in our equation, then C is my right angle. So then I'm going to name this side A, little a, and then this side B. And so then what I know is that the two legs squared and added together is equal to the hypotenuse squared. So we're going to try 2. Alright, so what I know is that c squared equals a squared plus b squared, and that c is always my hypotenuse. So let's take a look at example 1 first. In example 1, x is my hypotenuse, so I'm going to plug x in for c. Equals, and then it really doesn't matter who A and B are. It honestly doesn't because they're both legs. So you just do 10 squared plus 24 squared. It won't matter because you're adding them anyway, so you can add in any order. And we're just going to square everything. I don't know what x squared is, so I'm going to leave it. This is 100, and then plus 24 squared, which is 576. Some of these numbers are rather large, so you might want to have a calculator handy. So then we get that x squared equals 676. Now to figure out what just x is, the length of the hypotenuse without the squared, hopefully you remember to undo squared, you square root both sides. Okay, so we get that x is equal to 26. Now on this one, example 2, I still use c squared equals a squared plus b squared. However, this time I identify my hypotenuse. And it's a number, so I'm going to plug it in there, 20 squared equals, and again, my legs can go in any order, it doesn't matter, so x squared plus 8 squared. I'm just going to square everything again, so I get 400 equals x squared plus 64, and then I just want to get x all by itself, so I'm going to subtract the 64 away, and I get 336 equals x squared. And I'm going to square root both sides to get x totally alone. And now with this one, you guys, square root of 336 is not perfect. However, it does reduce. Hopefully you remember how to reduce radicals. The perfect square 16 times 21 is 336. And I know the square root of 16. However, I don't know the square root of 21. So when I get x here, it will equal 4 square root 21 because the square root of 16 is 4 and the square root of 21 I don't know, so I just leave it square root 21. Hopefully you got that. This simplifying radicals bit, I know we did a lot in algebra last year. If we need to review it a little bit tomorrow, we can go over that, but just do your best tonight on the problems like these. Now remember, this is using the Pythagorean theorem. You know that it's a right triangle because it has this little boxy in it, so you can use this theorem. Because now I want to talk about the converse, which is a little bit different. So as I was saying, the converse of the Pythagorean theorem says that if I have that c squared does equal a squared plus b squared, so in this case they're going to give you some side lengths and you have to plug them in to see if this holds. If they do in fact equal each other, then what you know is that triangle ABC is a right triangle. Now the kind of cool thing is you can figure out, if it's not a right triangle, you can figure out what type of triangle it is, acute or obtuse. That's because since C is my hypotenuse over here, if the hypotenuse is longer than the two legs, so if we have that C squared is greater than the A squared plus B squared, so I have a really long hypotenuse with two shorter sides that add up to smaller than that, then I have that triangle ABC is an obtuse triangle, which is pretty cool because this is my hypotenuse, remember? So if that is bigger than the two legs, then it's got to be obtuse. So then also we could say if C squared is less than A squared plus B squared, hopefully you can assume the answer here, that triangle ABC is acute, a cutie triangle. Which we shouldn't just assume, we should prove, but we'll take it for now, and let's try a couple problems where we classify the type of triangle. So I'd like to identify what kind of triangle I have, and remembering our Converse that if I have that the hypotenuse squared is equal to the leg squared, then that is a right triangle. If I have that the hypotenuse is greater than the leg squared, that's going to be obtuse. And then if my hypotenuse is less than, I have a cutie. So let's try this guy out. In example 1, we have the sides 6, 11, and 14. Now you're probably wondering, how do I know which one the hypotenuse is? Well, since the hypotenuse is always across from 90, it's going to be the biggest side in your triangle if it's right. So you always assume that the largest value is your hypotenuse. So we're going to start with that one. So we have 14 squared, and then I don't really know what symbol is going to go here yet, and then I just do 11 squared plus 6 squared. And I got to figure out what symbol is supposed to go there. Are they going to be equal so that's right? Is it going to be greater than so it's obtuse, or less than so it's acute? So now we just got to do a little bit of math. So 14 squared is 196. Still not sure what my symbol. 121 plus 36 over here. 196 is, I'm about to decide, and then this side is going to be 157. So 196 is clearly greater than 157. Because I have a greater than symbol, I know that it's an obtuse triangle. Pretty cool, huh? So let's try another. We want to use 9 as my hypotenuse because it's the longest side. So I have 9 squared. Not quite sure what's going to happen with my symbol. Then I just list the other two numbers, 8 squared plus 7 squared. So 9 squared is 81. Still not sure what my symbol is. 64 plus 49. So then I have 81, and I'm about to decide what my symbol is 113. Yeah, so clearly 81 is smaller than 113, so this guy is going to be an acute triangle. Pretty cool, huh? When we're smaller than, we got to be acute. And then lastly, let's try this guy here. Again, I'm going to use 10 as my hypotenuse. Not sure what my symbol is going to be. 8 squared plus 6 squared. So I have 100. Not sure my symbol yet. 64 plus 36. 100, and I'm about to decide. Pretty sure those add up to 100. So now I have that they are equal, and when we're equal to, we are a right triangle. So those are the examples that I have for you now. Do your best on this worksheet. You only have to do the odds. Try number 30 if you can, and then tomorrow we'll go over it and do an activity in class and hopefully be able to complete our homework for tomorrow in class as well. All right, have a good night, guys.